Hi, so we are looking at some enthalpy problems. So the first one, video problem 3A, is dealing with this reaction. 2H2O liquid going to 2H2 plus O2 gas. And what we are looking at is what happens when 25 grams of liquid water reacts. So first of all, let's look. We have delta H equals 572 kilojoules. It's positive. So that means heat is entering. That means heat is a reactant. So 572 kilojoules plus 2 H2Os goes to form 2H2 plus O2 gas. What this means is that if 2 moles H2O reacts, that's going to need 572 kilojoules of heat. Well, what happens if 25 grams? What I need to do is I need to convert from 25 grams to moles. And once I know how many moles, I can use this fact, kind of like I use stoichiometry to figure out how much heat is required. Okay, so 25 grams H2O, how many moles of that is that? Okay, so what I'm going to do is I'm going to use my molar mass. This is H2O. So I look at the periodic table. Here I have it. I have hydrogen 1.008. So 2 times 1.008. And then plus 15.999. And so that's going to get me 18.015 grams, 1 mole. Grams cancels out, and that's going to get me 1.388 moles H2O. So that's how many moles are reacting. So now, if I have 1.388 moles H2O, well, what this tells me is for every 2 moles, I need 572 kilojoules. That means for every 2 moles, I have 572 kilojoules. The moles are going to cancel out, and that's going to give me the number of kilojoules. In this case, 397 kilojoules of heat are required. Notice that 1.388 is less than 2, so it makes sense that I have less than that 572 kilojoules. Let's go over this one more time. Okay, so here is my solution, 25 grams to moles, and then I go ahead and I use this like stoichiometry to figure out 397 kilojoules. Let's move on to video problem number 3B. So 3B is dealing with heats of combustion. So in heat of combustion, what we're always looking at is how much heat per 1 mole of any compound. So we're asking for the reaction for octane. Octane is C8H18 liquid. And we're going to burn it. Okay? We're going to burn it. So we need to think back to 215 when we were first talking about combustion. So that's C8H18 liquid plus O2 going to CO2 plus H2O. These are gas because I know that burning things produces a lot of heat. So these are going to be in the gas phase. All right, so this is not balanced, so I need to balance it. I have 8 carbons here, 1 here. I have 18 hydrogens here. I have 2 here. I have 2 oxygens here. I have 3 here. So it's not balanced at all. So in 215, I learned that where do I start? Well, I don't know quite where I start, but I know I end with oxygen. and then usually hydrogen. And so carbon is where I'm going to start. So I have 8 here, 1 here. So I'm going to put 8 there. That's going to balance that. But now I have 16 plus 1, so I have 17 oxygens. Okay, now I'm going to move on to the hydrogens. I have 18 here, 2 there. So I need to balance this. I'm going to put that. Okay, so that's going to balance my hydrogens. But look, now I have 16 oxygens. And then I have 9 here, so I have 25 oxygens. Okay, so I have 2 oxygens here, 25 there. So it's really not balanced. All right, so I need to balance it. And what I should do is I should look and I should say, I need to get 25 oxygens. So what I need is, I need 25 over 2 times 2. That's going to get me my 25. So this is my balanced chemical equation. Now, this is balanced. In 215, I said, hey, we need to get rid of this. So I would make this 2, this 25, this 16, and this 18. But in Chem 216, we're going to actually leave this where we have a fraction here. And we're going to do that because of the definition for heat of combustion. And that's per 1 mole. So I'm going to leave this as that. And that's the equation for heat of combustion. Let's review this. Oops, sorry. If I review this, I can see here that I made sure that everything's balanced. And I leave this even though it's a fraction, because I need to have 1 mole. All right, let's move on to 3C. 3C, we're now looking not at heats of combustion, but heats of formation. So heat of combustion was, I'm going to burn whatever I'm looking at. Heat of formation, I'm actually going to form it. It's going to be a product. So I have A, B, and C. So A, I'm forming C2H5OH. And in B, I'm forming O2. So in A, I'm going to make C2H5OH. What am I going to make C2H5OH from? Well, from carbon, hydrogen, and oxygen. Notice that hydrogen's there twice. So do I have another hydrogen? No. Hydrogen here, hydrogen there. It's all coming from hydrogen. Okay, so I need to balance this. Or first I need to figure out, well, carbon in its natural state, that's solid carbon. Hydrogen in its standard state, that's H2 gas. And oxygen in its standard state, that's O2 gas. These are what we need to know. This is just what hydrogen and oxygen are in nature. Okay, so if I look at this, I can say that it's not balanced. I have 1 carbon here, I have 2 there, so I'm going to put a 2 there. I have H2. Here I have 6 hydrogens, so I'm going to put 3 there. And then I have 2 oxygens here. I only have 1 there, so I'm going to put half. All right, so this is my reaction for the formation of C2H5OH. Let's do B. In B, we're forming O2 gas. All right, so what do I form O2 gas from? I form it from oxygen. What's oxygen in its standard state? O2 gas. So I'm going to make O2 gas from O2 gas. So this isn't really a reaction, right? So the delta H for this reaction, seeing that nothing's really happening, it's going to be 0 kilojoules per mole. because if I'm looking at the delta HF for any compound and it's in its standard state, its delta HF is 0. All right, let's just review this real quick. We have our first one, which is ethanol. We're gonna forming it from carbon, H2, and O2. I need to add coefficients there to balance it out, right? Remember, in heats of formation, whatever I'm forming, that's my product. All right, B, I'm forming O2 from O2, and so I get a delta HF of 0 kilojoules per mole. All right, talk to you later.